Okay, we'll solve Pascal's triangle value now. Given a row and a column in Pascal's triangle, return the value in the given row and column. Now, this may seem difficult to do because Pascal's triangle, if we look at Pascal's triangle, we see, like, if we're given row 0, column 0, that's this one. But row 0, row 1, row 2, row 3. Row 4, column 1 should be that 4. Row 4, column 2 should be that 6. And it sure looks like we're going to need some sort of loop in order to compute this. But we don't, because there's a formula. Given a row and a column, here it's just using n and r. The value at that row and column is, well, n factorial over r factorial, n minus r factorial, which is row factorial over col factorial, row minus col factorial. This is the formula we need, which is also known as n choose r, by the way, which is also how Pascal's triangle ties into combinatorics and into probabilities, which is what motivated Pascal to make it in the first place. In any case, we'll come here and we will write it was row factorial over col factorial times row minus col factorial. Okay. Now that's not going to work because it turns out factorial is in math. Oh, so it's math dot fact. Oh, having trouble typing here. There we go. Pardon me. Math dot factorial and math dot factorial. Okay. So this looks like our answer. And it's not going to work, but it's a start. We run it. It failed because, let's see, it said use assert almost equal for floats. So we're actually returning a float. Sure we are, because of the division. See, this is float division. And we can turn it into integer division, but that's not the best answer because when you're dealing with floats, things can go wrong in subtle ways. It's better to round. So we'll go ahead and round the answer to get it to the nearest integer. And now, well, we get this weird error that says rounding in Python is, in Python 3 actually is different from Python 2. And in Python 3, rounding can be surprising because when we round 2.5, we don't get 3, we get 2. It's called round to nearest even. And that's not what we want here. So it turns out that as the error message continues, you should use round half up. Round half up is what we probably learned in school, where if you have any number ending in 0.5 that's positive, you round to the next larger value. You round with ties going away from 0. You don't need to understand how this function works. We literally give it to you. Just copy paste that. By the way, there's also round half even, which is what the built-in does. And here's that function as well. Now the good news is we actually supplied round half up in this file for you. So you don't even have to copy paste it. You get to just use it. So instead of round here, we'll do round half up. It still doesn't work, but it's better. So now, oh, and actually our line width is beyond 80 characters. So let's go ahead and do this. You can't have line width beyond 80 characters. Now, we didn't pass. We knew we wouldn't, but we did better. Factorial not defined for negative values. Why? Well, what test were we doing? We're doing Pascal's triangle value of 3, -1. Row 3, column -1. It makes no sense to have a negative column. But let's go back to the problem statement, and let's read it more carefully. It takes int values. It doesn't say non-negative int, so it could be negative. And now, if either row or column are not legal values, return none. Aha! A careful reading of the problem tells us what to do in this case. It also says, don't crash. So what we had to do was, in our problem here, we had to say, hey, wait a minute. If the row is negative or the column is negative, go ahead and return none. This is close to correct. We run it and still didn't pass. It didn't pass now. Let's see why. So the test case was 3, 4. Okay. Well, row 3, column 4. Well, but that again doesn't make sense because in row 3 you can only have columns 0, 1, 2, and 3. In fact, in any row, the largest column is in fact the same as the row. So we are also illegal if your column is greater than your row. And now when we run this, we passed. Huzzah! And that is Pascal's triangle value.